Good morning, students. Let's begin our next topic of chemistry portion, chapter number 1, that is matter in our surroundings. So in the previous video, we have learned about what are matter, how it is made, and what are its physical types. So today we'll be learning about standard unit of temperature, which is called as SI, unit of temperature. So these are the temperature units which you have seen that we follow in our daily life. About we know the temperature in degree C. So degree C is a common measuring unit of temperature. In some countries people also use Fahrenheit. So Fahrenheit and degree C are very common, or degree Celsius we may say that, are very common measuring units of temperature. But internationally we follow some unit of temperature when we do some chemical experiment in chemistry. We have to control the temperature in physics. In scientific experiments and practicals, we don't use the common measuring units of temperature, but we use some standard unit of temperature. So standard unit of temperature is different than this common measuring units. So before we start, we should know what are the common measuring unit we use maximum times. So commonly temperature like melting point, boiling point, etc. is measured in degree Celsius. So degree Celsius we use most, that is we call it a degree C. So we draw like this, a simple zero, a small zero, and then we write a capital C. So this is the degree C which we use as, so which is written as a short form as degree C, which is read as degree C. So here we write a degree, small degree here, and then we read as degree C. So when we'll find, or when we'll measure melting point and boiling point of water in terms of common measuring temperature unit, it will be 0 degree C. You have also learned in your previous classes, you would be knowing it already. So melting point of ice on Celsius scale of temperature is 0 degree C, and boiling point of water on Celsius scale is 100 degree C. Here degree C means degree Celsius. Okay, now unit of measuring, SI unit of measuring temperature. So the SI unit of measuring temperature is Kelvin. It is Kelvin. So Kelvin is the standard international unit of measuring temperature, which is denoted as symbol K. So capital K is the symbol of Kelvin, which is always a positive unit. That means sometimes you would have seen that we also write temperature at -2 degrees C, or -10 degrees C, or even -40 degrees C. Okay, so but here this Kelvin unit of measuring temperature is always a positive unit. That means it will never fall below 0. It will never fall in the negative unit. It will always be in the positive unit. And we don't have to put any degree sign on the Kelvin. So we just have to write a capital K for Kelvin. Okay, if we write small k, it will be wrong. Okay, we just have to write a capital K and no degree sign, nothing else. This is sufficient. So this is the standard measuring unit of temperature. So Kelvin is the standard measuring unit of temperature. So the next things which we'll be learning is that melting points on Kelvin scale. So just now we have read that how do we write melting point and boiling point in the terms of degree C. But then now when we write melting point of ice and boiling point of water, so we'll be taking example of water. Okay, because water is a only matter which can be present into all three physical states, that is solid, liquid and gas. No other metal can do this, but water is a versatile matter, element, we can, a compound, we can say that, not element but compound, which can be present or which can be converted into all the three physical states of matter. So melting point of ice on Kelvin scale is 273 Kelvin. So melting point of ice on degree C is 0 degree C, but melting point of ice on Kelvin scale is 273 Kelvin. Boiling point of water on Kelvin scale is 373 Kelvin, and boiling point of water on degree Celsius scale was 100 degrees C. So there is a relation between degree C and Kelvin. What is that? If we'll say that, okay, so if we'll find out, we have to find out Kelvin. Kelvin equals to degree C plus 273. So this will be your formula to find out how we will convert. There will be some questions in your NCERT book. Also, some more questions will be coming in your exam maybe, and some questions I will be giving you in the homework so that you can practice them. So that will be dependent upon this formula. So you have to know that if you want to find out what will be the not that question, but before we have to understand this as well. So how come it happened like this? Ki you have written melting point of ice is 273 and then boiling is 373 Kelvin. So it's simple, like you know that water ice water freezes at 0 degrees C and water ice melts at 0 degrees C. So if I write 0 here, like this is the melting point of ice plus 273. Okay, so what it be? 273 Kelvin. That means the melting point of ice is 273 Kelvin and the boiling point of water, since boiling point of water in degrees C is 100, and you have to add this. So 100 plus 273, 373, so Kelvin. So boiling point of water at Kelvin scale is 373. I hope you understood. I'll show you how. Relationship between Kelvin and degree Celsius. So temperature of 0 degree C is equal to 273 Kelvin. That means 0 degree C equals to 273 Kelvin. Please take screenshot of these pages so that you can write your notes using these key points. Now, temperature on Kelvin scale. How do we find out temperature in Kelvin scale? So temperature on Kelvin scale is simply temperature on Celsius scale plus 273, that is K equals to 0 degree C plus 273. So this is the standard formula for you people. You can easily learn this. It's not that difficult. It's very easy and you can find out. So next is the main points. I'll just read out these points. I'll just explain you. I hope you have understood already. But those who haven't, please pay attention on what I say. And then we'll be doing some questions also. To convert a temperature on Celsius scale to Kelvin scale, we have to add 273 to the Celsius temperature. So if we have to convert our temperature from Celsius scale to Kelvin scale, like I have done here, I have converted my temperature from Celsius scale to Kelvin scale. Then I will be adding, I have to add this, okay? I have to add 273 on our Celsius temperature, like we have done here. Then to convert a temperature on Kelvin scale, if you want to convert temperature on Kelvin scale to degree C, then we have to subtract. For example, if we want to convert our temperature, like I have this 373 Kelvin and I want to convert it into degree C. So I want to know that how much temperature this 273 degree is in degree C, in degree Celsius. So I just have to subtract 273, like okay, degree C equals to 373 minus how much I will subtract? 273. Okay, so when I will be converting my temperature from degree C to Kelvin, I have to add, and when I will be converting my temperature from Kelvin to degree C, I will have to subtract. So please keep these things in your mind. So temperature would be simple, 100 degrees C. I hope it's clear. To convert a temperature on Kelvin scale to Celsius scale, we have to subtract. So I'll repeat once again. When we have to convert our temperature from degree C scale to Kelvin scale, we have to add 273, okay, from degree C to Kelvin, okay. And when we have to temperature from Kelvin to degree C, we have to, it will be degree C equals to whatever temperature we are having, it is Kelvin minus 273. That will be our degree C value. So we have to add when we have to convert from degree C to Kelvin, and from Kelvin to degree C we have to subtract this. Here I have written one question, so just we will be doing this. Convert the temperature of 25 degrees C to Kelvin scale. So here we have to convert our temperature from degree C to Kelvin. So I've told you, when we have to convert from Kelvin degree C to Kelvin scale, what we'll do, we will just write the formula here, K equals to degree C plus 273. Okay, so we'll be doing according to this formula. So answer will be 25 here is written. So simple, Kelvin equals to degree C equals plus 273. That means whatever the temperature is given in your Celsius. So it will be 25 plus 273, which is 298 Kelvin. So the answer is Kelvin. I hope it's clear. So we will do next question. Next question is, convert the temperature of 300 Kelvin to the Celsius scale. So here we have to convert our temperature from Kelvin scale to Celsius scale. That means the answer or the formula will be degree C equals to Kelvin minus 273. Okay, please don't forget this. So simply what we'll do, temperature on Kelvin scale, or we all can also write list like this, that Kelvin, same formula, but you have to just write, you just have to write the that question again. You can also use, if you want to use this, you can use this, and then when you will convert, you will change this here, it will be in minus. I hope you know that it will be in minus, or you can skip this, you can just learn this, that degree C equals to whatever the Kelvin is given, 300 minus 273. That will be more easy for you. It is 27 degree C. Clear? I hope you understood. So I'll be giving you such questions for your homework. Please check out your homework section from the student's ID in the software. You can find out your homework there, and you have to submit your homework in a sheet. You have to write in any, you can write in any register, anything which you are having, any plain sheet, you can write on that. You have to click your picture, and then you have to upload it into your homework section. Now moving next with this, we will be learning about change of state of matter. So this is we have finished our temperature. So next is change of state of matter. So we know that matter can be in any state, like it can be in solid state, it can be in liquid state, it can be in gaseous state. So how can we change these states of matter? We can simply change the state of matter by changing the temperature or by changing the pressure. So in this video we'll be just learning about change in temperature. In the next video, or after another video, I'll be taking this change in pressure, because change in temperature is a bigger, lengthier topic. So we'll be having one more topic in this. So for now we'll be taking this change in temperature. So by changing these two things, we can change the physical state of matter. That is, we can convert solid state into a liquid state, and then we can convert liquid state into gaseous state. Again, we can convert gaseous state into liquid state and then solid state. So all this interchange of states can be done either by change in temperature or by change in pressure. So effects of change of temperature. So when we will change in temperature, what will happen? Solid to liquid change. So when we are having matter in any solid state, for example, we are taking here as a water. So matter is a compound which can present in all three states, that is solid, liquid and gas. So we'll be taking example of water only. So solid to liquid change. So when we have water in a solid form and it converts into liquid form, or a solid form changes into liquid form, we call it as melting. So conversion from solid to liquid is called as melting. The process in which a solid substance changes into a liquid on heating. How is this melting done? It is done by heating. So the process of conversion of solid into liquid by heating or by little rising in temperature. If you have ice and you have just kept it out from the refrigerator and you're not even heating the ice, still the state of matter is changing. That is, somehow it is rising, the temperature is rising up. So not only by heating or by just rising the temperature. So when there is a change in temperature, when temperature rises up, that means the change of solid is converted into liquid. That is called as melting. Okay. We can also take an example of any iron. If we will heat any iron rod, if we'll rise the temperature, it will start melting. So metals also behave as liquid when they are heated or when the temperature is raised. So the temperature at which a solid substances melts and changes into liquid at atmospheric pressure. So the temperature in which any solid converts into liquid is called as melting point. So when we talk about melting point, it not only depends upon the water, but also to other substances as well. Like if we learn about melting point of iron, it will be different. Melting point of sugar, melting point of salts. So any solid which converts into liquid at a particular temperature, so that is called as melting point. So example, the melting point of water is, the melting point of ice is 0 degree C. Okay. So next is liquid to gas change. When we convert solid to liquid, it is called as melting. Okay. So but when we convert liquid to gas, when liquid is converted into gaseous state, it is called as boiling, or we call it as a vaporization. So the process in which a liquid substance changes into gas rapidly on heating. Again, when we convert a solid into liquid, we have to rise the temperature, and when temperature is rising up, it is very high, then that liquid tends to convert into vapor form. For example, if you are having ice and you just keep it in a pan and you heat it for a while, it will convert into water. And then if you heat again, if you keep on heating, the water will be get vaporized. That means it will convert into vapors, and that process is called as boiling. So the temperature at which a liquid boils or changes rapidly into a gas at atmospheric pressure is called as boiling point. When we boil something, or when any liquid starts boiling, or when any liquids convert into gaseous state, we call it as a boiling point. At the temperature, at the minimum temperature, when any liquid starts to behave as gas, the minimum temperature, that is called as a boiling point. For example, the boiling point of water is 100 degree C. And what is the boiling point of water at Kelvin scale? Please recall it. Yeah, it is 373. How? Because to find out the Kelvin scale, we have to have a formula that degree C plus 273. So degree C is 100 plus 273 equals to 373 Kelvin. Very good. So next is gas to liquid. So we have learned about solid to liquid is called melting. Liquid to gas is called as boiling or vaporization. Then gas to liquid, when we have to convert gas into liquid. So we'll take a simple example. If you have taken ice and you'll keep it in a pan, you'll heat it for a while, you'll see that the ice is converting into water. That means due to the increase in temperature, the ice has converted into water, liquid state. And then we'll heat it more, it will convert into vapors. And then those vapors, if we'll put a plate on our pan, we'll find out those vapor will, when condense, will again convert into liquid. So when gases changes into liquid, it is called as condensation. The process of changing gases to a liquid by cooling is called as condensation. So condensation is a kind of a reverse of boiling. When we boil, we convert liquid into gas, but when we undergo condensation, we convert gas into liquid. It is like a reverse of boiling. Okay, so last is liquid to solid change. Okay, So again, liquid is converting into solid, that is called as freezing. So for example, let's go with an example on all at once, that you have ice. You you have taken your water, you have freezed it, it's ice, you have heated it, it got melted, you have heated it more, it turned into vapors, and then you collected the vapors, you condense the vapor, you get liquid again, and when you freeze the liquid you will get ice again. So liquid to solid state is called as freezing. The process of changing a liquid into a solid by cooling is called as freezing. So these are the four process by which we can change the temperature, and we can convert one state of matter to the other state, and then from that other state to a next stage. So simple diagram for you is that you have to learn this diagram. This is an important kind of diagram for you. It's like solid state. This is called as an interconvertible state of matter. How one state of matter is converted to other state, and then to the other, and from the other to the next stage, and then to the previous stage. So it is called as interconvertible stages of matter. Solid state. So if we'll heat it, it's called as melting. Solid to liquid is called as melting, and it is done by heating. So if we increase the temperature, so it will convert from solid state to liquid state. Again, if we will heat the temperature, this is called as boiling. Okay, so solid state to liquid state called melting. How? The change in temperature. How? When we will rise the temperature, we will increase the temperature. So basically we'll give heat here. From liquid state to gaseous state, again we will rise the temperature, we'll heat it. That is called as boiling. So the process or the conversion state from liquid to gaseous is called as boiling. Then again from gaseous state conversion to liquid state, it is called as, we'll cool it, and it is called as condensation. Okay, so condensation, and temperature is lesser. Now we will decrease the temperature, and from liquid state to solid state it's cool, freezing. So these are the interconvertible states of matter. Solid to liquid by increasing temperature called as melting. Liquid to gaseous is called as boiling. Again temperature will be increased. Then from gaseous state to liquid state, temperature is decreased, called as condensation. And from liquid state to solid state called as freezing, which is due to cooling. So these are the interconversion states of matter. Here I have to tell you a simple thing is that when we will heat liquid, its physical states become gas. So when we will heat any liquid, so its physical state will become gas, and when we will condense any gaseous states, its physical state will become liquid. And here also, if we will heat solid, its physical state will become solid, and when we will freeze solid, its physical state will become and when we will freeze any liquid, its physical state will become solid. How all these things happen? Since I've told you that this was the arrangement of particles of matter, if you remember, for solid, for liquid, in the previous video I've told you, and in the case of gas, so they have some characteristics. Okay, so these characteristics were that particles of matter are always moving, particles of matter have space between them, and particles of matter attract each other. So despite of all these three characteristics, there are three states of matter. They behave at different form of matter because the particles of arrangement is different. Like in solid, it's very densely packed, so they don't have much space to move. They just vibrate at their own axis. So because they are so densely packed, that is why solids are hard and rigid. Okay, and liquids are like this, they are free flowing, and gases are so away from each other. Particles are that they are like this. So if these solids are allowed to liquid and gas. So if these solids are allowed, particles of solid are allowed to be like this or to behave like this, that means the solid is converted into liquid. So when we heat any solid compound, any solid material, the force of attraction between these particles somehow loses. So by melting this solid or by heating these solids, this force of attraction breaks and the space becomes larger. When the space becomes larger, the particles move away from each other, so they behave like this. The arrangement becomes like this. When the arrangements of particles becomes from this to this, then the state is called as a liquid state. We know already. So that time the solid is converted into liquid state, and this is by heating. When we heat, the particles will gain the kinetic energy. So this kinetic energy, if you remember, I have told you in the previous video, please go through the definition which I gave you. So this kinetic energy will be increased, which will allow these particles to move even faster. And when they will move faster, they will be away from each other. They will behave as a solid and it will behave as a, they will behave as a liquid, and hence the state of solid will be converted into liquid state. Again, we will heat it more. Again, it will have more kinetic energy. So when it will have more kinetic energy, the speed of the particles will increase and they will be away from each other. They can be freely moving. So they will be away from each other. There will be lesser attraction. So they will behave as gas. So this is how the solid converts into liquid and liquid to gas. Again, if we will decrease the temperature, so there will be lesser kinetic energy, there will be lesser movement of particles of matter. When they will not be able to move, they will behave like liquid. And then when we will again lesser the temperature or decrease the temperature, they will behave like this and they will be called as solids. So this is like an interconversions of matter. This is how it changes. I will be telling you in more details in the next video, but for now please go through the video very carefully. Wherever you feel that you can take screenshots, you can write down the notes, you can write the important topics, and please do your homework. That will be also helping us to mark your presence or attendance in there. And do your homework and stay safe. Thank you.